Hello everyone and welcome to lecture number 2. This is the second lecture. In the first lecture we have seen some of the introduction to the unit and we have tried to understand that what is two-wire transmission line, what is its equivalent circuit diagram, and we have derived some of the steps to get the relation of current and voltage. In voltage we have got the equation with respect to the incident voltage and reflected voltage. In current also we have got the same. Now going ahead, we have another term to understand, that is characteristics impedance. That is characteristics impedance. Characteristics impedance the another term is characteristics impedance. Now, as we know that, as we have already studied, that in the equivalent circuit diagram we have resistance, we have inductor, we have capacitor, we have transconductance, that is conductance, right? So inside this circuit, the value of R will be a real quantity, right? But the impedance offered, or the resistance offered by the inductor L, will be an imaginary quantity that is being given by J omega L. That is imaginary quantity, right? So the total resistance, or the total resistance offered by the transmission line, is known as characteristics, is studied with the help of characteristics impedance, right? Is studied with the help of characteristic impedance. Now, by definition, what is the characteristics impedance? Is characteristics impedance of a transmission line, impedance of a characteristics impedance of a transmission line is nothing but the impedance measured at the input, right? The impedance measured at the two input terminal of a transmission line when its length is infinite. When the length is infinite, right? When the length is infinite, when this length is infinite, this is infinite, and if we measure the characteristics impedance over these two terminals, over here and over here, then that is known as characteristics impedance. Let us see the definition of it, that how the definition can be written off by that of characteristics impedance is, and we will derive some of the equation for characteristics impedance. Characteristics impedance Z0. Characteristics impedance is represented by Z0. Z0 is the symbol to represent characteristics impedance. Z0 of a transmission line characteristics impedance Z0 of a transmission line is defined as the impedance defined as the impedance measured at the input terminal of the transmission line of the transmission line when its length is infinite. When its length is infinite. This is all about the definition associated to the characteristics impedance, right? Impedance, why we are considering impedance? Why not resistance? Because we also have an imaginary component, that inductor and capacitor. Those components are active devices and they have a reactance or impedance part instead of resistance, that is an imaginary value. So we have to consider impedance. Impedance is nothing but the addition of real resistance and reactance, right? And imaginary resistance. Okay. Now let us see some of the steps how to derive the equation for characteristics impedance. That is, we already have equation dV by dx is equals to minus of r plus j omega L into I, right? We have this. Therefore, I is equals to minus of 1 by r plus j omega L into dV by dx. Let us say this is equation number 1. This is equation number 1. Now, going ahead, we know that what we have is, this is equation number now, equation number 1, we already know that, we know the equation of voltage, that is total V is equals to Vs e raised to minus gamma x plus V r e raised to plus gamma x, where over here this S quantity, this is the sending wave voltage, this is the reflected back voltage, this is the reflected back voltage, right? Now further differentiating this equation, differentiating the above equation with respect to x, we will be having dV by dx is equals to gamma into V2 e raised to gamma x minus V1 e raised to minus gamma x. Differentiating this equation, you will get this, right? Instead of Vs, this Vs, we have write V1, this Vr, we have write V2, right? This Vs is nothing but the incident voltage, this is nothing but Vs, this is S, This is VR, this is VS and VR. Okay, don't get confused because we are writing in terms of voltage V1 and V2 now. Now, substituting this value of dV by dx, equation 2, this is equation 2, substituting in equation number 1, we will be having, we have I is equals to plus, because minus sign will get common, plus 1 by R plus j omega L into gamma V1 e raised to minus of gamma x minus V2 e raised to gamma x. This minus sign we are taking common. This minus sign we are taking common over here. So V1 will be positive over here, V2 will be negative over here, and in equation of I, we know that I is equals to minus 1 by R plus j omega L dot dV by dx, it was there. So minus from this component and minus from this component will cancel, it will be plus over here, right? So don't get confused. Now, substituting the value of this gamma, we have substituting the value of this gamma, we have value of gamma and substituting in the above equation, we get I will be equals to I, that is nothing but current, will be equals to root of R plus j omega L, root of R plus j omega L into G plus j omega C into V1 e raised to minus gamma x minus V2 e raised to gamma x divided by R plus j omega L. So this is the equation that we will be getting after substituting the value of this gamma. After we will substitute value of this gamma. Gamma is nothing but R plus j omega L into G plus j omega C. In the previous theory, we have already studied this relation gamma square. We have derived that. We have assumed in the previous theory. Now moving ahead. This I will be equals to this term and this term will get cancelled out, and we will get a whole term under root, that is G plus j omega C divided by R plus j omega L into V1 e raised to minus of gamma x minus V2 e raised to gamma x. Right? This is the basic fundamental equation. Now you can think of, just imagine in the previous term that this whole term is corresponding to voltage, right? And if this is corresponding to voltage, this whole term is corresponding to voltage, I can write this as V. I can write this as V. If this whole voltage is corresponding, this whole term is corresponding to voltage, then I can write as V, because both are voltages and they will have a corresponding voltage, total voltage. Now we know that if I take it over this side, if I take this V on the another side, then I by V will be equals to this term, G plus j omega C divided by R plus j omega L. But as we know, I by V is nothing but is equals to 1 by Z0. Therefore, I by V is equals to 1 by Z0. We know that V is equals to I into R. Now, why we have taken Z0 over here? We have taken Z0 over here because we have the imaginary terms. We have the imaginary terms in the circuit, and that are forcing us to study the impedance of the two-wire transmission line instead of a simple resistance. So the value of Z0 will be the inverse of this term, because it's inversely proportional. So Z0 is equals to root of R plus j omega L divided by G plus j omega C. This is the required equation of characteristics impedance. This is the required equation of characteristics impedance, right? We also do have the another definition. Of characteristics impedance, that is when the reflected wave in the line, in the transmission line, is 0, then the ratio V of, let us say, length x is nothing but the amount of length, is called the characteristics impedance of the transmission line. So this is all about the characteristics impedance of a transmission line. Okay. Further, the next topic is the reflection coefficient rho. That is nothing but reflection coefficient rho is nothing but the ratio of reflected voltage to the sending voltage. Reflection coefficient, that is reflection coefficient rho, and it is defined as the ratio of it is defined as the ratio of the reflected voltage to the incident voltage at the load terminal. At the load terminal. If we see the simplest form of the circuit, then this is a 2-wire transmission line of length L. This is 2-wire transmission line of circuit of length S. This is the end point. This is the end point of a transmission line and having resistance ZL. That is the load resistance, right? That is load resistance. Then Vs e raised to minus of gamma L, and this is Vr e raised to plus of gamma L. Right? The upper term is, this is for the sending wave, means the wave which is going to ZL, and this is for the reflected wave, means the wave which has been reflected from the load towards this side, which has been coming back, reflected towards that, right? Now let us derive the relation between the reflection coefficient and ZL and Z0, that is characteristics impedance. So that will begin with the total voltage equation given by voltage is V is equals to VL at load is equals to Vs e raised to minus gamma L minus of plus Vr e raised to plus gamma L plus Vr e raised to plus gamma L. Right? Now we know that rho is equals to Vr by Vs by its definition. By its definition, we know that reflection coefficient rho, this is reflection coefficient, rho is equals to, then this will be equals to V of R e raised to gamma L divided by Vs e raised to minus gamma L is equals to Vr by Vs into e raised to 2 gamma L. This is nothing but the relation of rho with respect to Vs and Vr. Now, usually this rho reflection coefficient will be a complex quantity. We will not include all those things, complex things, but as it is been included in the theory, you will see some of the things. Usually rho will be a complex quantity and can be expressed in polar form as rho is equals to rho e raised to j of psi, where psi is the angle of reflection coefficient. Psi is the angle of reflection coefficient. Now, moving ahead, we will not include this angle part in the rest of the calculations. That is, we know that the current at the load is given by I of L is equals to Vs. I is equals to V by R, but as V is containing two terms, that is Vs and Vr, and R is nothing but Z0, so we are directly writing that equation. Don't get confused. Divide by Z0, Vs divide by Z0, and minus Vr e raised to gamma L divided by Z0. This is nothing but IL. That is the current at the load. Right? Now moving ahead, we also have, and we know that ZL is given by VL by IL. This is nothing but the load impedance. ZL is nothing but load impedance is given by VL by IL. Now what we are doing is we are substituting the value of VL. We are substituting the value of VL and IL. We are substituting the value of VL and IL in this equation. Then we will get, now ZL will be equals to Vs e raised to gamma L plus V of R e raised to gamma L divided by Vs e raised to gamma L divided by Z0 minus of Vr e raised to gamma L divided by Z0. Right? Divide by Z0. This will be minus, and moving ahead, now dividing this obtained equation, dividing the above equation by Vs e raised to minus gamma L. Dividing the above equation by Vs e raised to minus gamma L, then we will get that is Z of L is equals to Z0 into Z0, V of L Z0 into 1 plus V of R divided by V of S e raised to 2 gamma L divided by divide by 1 minus V of R divided by V of S e raised to 2 gamma L e raised to 2 gamma L. So we have reached up to ZL is equals to Z0 into 1 plus V of R by Vs e raised to 2 gamma L. We are dividing the whole equation by Vs e raised to minus gamma L, right? Dividing the whole equation by gamma L. This Z0 is coming from this side, taking common and going to the numerator, right? Okay, so this is nothing but, you can see this part is nothing but rho. This part is nothing but rho. Specifically this part, only this part is rho, is nothing but rho. So rho can be written as ZL is equals to Z0 into 1 plus rho by 1 minus rho, right? This is known as 1 plus rho by 1 minus rho, and this is the obtained equation, and we can also have vice versa of it, and we can have reflection coefficient is equals to ZL minus Z0 by ZL plus Z0. So these two are the required equations for what we are interested to study: the reflection coefficient, relation with the characteristics impedance, that is Z0, characteristics impedance and load impedance. Characteristics impedance and load impedance having a relation with the reflection coefficient. Reflection coefficient, right? This is nothing but all about the reflection coefficient. Okay, thank you.